Okay, welcome to 3.2, Pearson's correlation coefficient, R. So there was this guy named Pearson who came up with a statistic which he called R, which summarizes the strength and the direction of a correlation. So it's a way to be more precise about whether or not you have a correlation, how strong it is, and what direction it's in. There's a formula for it. I'm not going to have you worry about that, but I do want you to understand how it works. Okay, so Pearson R tells us two things. It tells us the strength of the relationship, whether it's strong, weak, or non-existent, and it also tells us the direction of the relationship, whether it's positive, another word for that is direct, so the variables move in the same direction, or negative, inverse, they move in opposite directions. So a positive relationship, remember, it's something like your thumbs move in the same direction. So if you could see me, I'm putting both thumbs up. I'm saying as depression goes up with one hand, self-esteem, as depression goes up with one hand, anxiety goes up with the other hand. Let's say those move together. Or if it's an inverse relationship, as depression goes up, self-esteem goes down. That's a negative or an inverse relationship. So with Pearson's R, the values range from -1 to +1. So it tells you the extent to which you have a correlation by how far you are away from zero, and it tells you how strong it is. It tells you the direction by whether it's positive or negative. So one thing to keep in mind is just because it's negative doesn't mean it's not a strong relationship. Negative just means which direction it's going in. Okay, and if it's near the middle, if it's if it's 0.0 something, there's a good chance that in the population there really is no correlation. We'll talk more about that later. Okay, so this just to give you some hands-on practice with thinking about it. I have here A, B, and C. There's 3 correlations, and what we're looking at is relationship between number of classes and stress level. And just imagine that we did a study a number of different times and it turned out a number of different ways. So in this first case, there looks to be a little bit stronger of a relationship because the lines are falling closer. And here, there's a little weaker of a relationship. And then B is probably the strongest relationship. So stop the program for a second and figure out which value goes with which letter. Okay, so you should have said the 0.26 is the weakest, that should be C. The 0.60, that's the one in the middle, that's A, and the 0.94, that's B. So C is weakest, A is a little stronger, B is the strongest. You'll notice with B, you have a line that's virtually at a 45-degree angle. The scores are falling very close to the line, very strong relationship. Whereas over here at C, the scores, the actual values that people got are falling a ways away from the regression line in most cases, meaning that the regression line doesn't do that great, the regression line is the summary of the relationship between X and Y. This red line doesn't do that good a job capturing what's going on because just the relationship between the two variables isn't that strong. Okay, and then in D and E, if you look at those, you have 2 other kinds of relationships represented. One of those is virtually no correlation, and the other one is a strong negative correlation. So stop the video for a second and see if you can figure out which one is the negative 0.77 and which one's the 0.03. Okay, so you should have said that the D goes with the negative 0.77 and E is the 0.03. So you can look here, the scores are falling away from the regression line. There's not a clear pattern in that high scores don't really go with high scores, low scores don't go with low scores. It's kind of all over the place. So you'll notice the regression line, that red line, is almost flat, saying there's almost no relationship between these variables. Whereas with D, there's a pretty strong negative relationship. It's negative because you've got high scores going with low scores. If you take 6 classes, you'll have a stress level around 10, and you got low scores going with high scores. Okay, so question 3, which is stronger, D or E? Well, pretty clearly, D is stronger because the line is at a sharper angle and the scores are falling closer. And which is the weakest of all 5 relationships? That would be E. All right. So this is something, don't worry, this won't be on the test, but I just want you to look at this scatter plot here and try to take a wild guess at what you think the R value might be. So for each scatter plot that we're going to have here, I want you to try to draw the regression line, take a stab at it, and then I'll show you what the real R value is and what the real regression line looks like. So go ahead and stop it for a second and take a guess. Okay, so what you should have, the line of best fit, the regression line that summarizes the relationship, would look like that. And the correlation is negative 0.46, which is a pretty healthy size correlation for the stuff we do. But you'll notice there's still a lot of variability around the regression line. In general, higher scores go with lower scores and low scores go with high scores. But when you're looking at the scatter plot, you might underestimate how strong you think that relationship is. Okay, activity 2 here, same thing. So just go ahead, stop the video, and take a stab at these two and see what you think. Remember, draw the regression line and also pick an R value. Okay, so this one, there's almost no relationship, right? The line's almost straight. Slight positive relationship. The R value would actually work out to 0.09. And down here, it's a stronger positive relationship. Look, the line steeper. The scores are falling a little closer to the line. If you want to do more of this stuff, say it's a Friday night, you're bored, you're on a date, you want to be entertaining, there's an online stats book that you can go to and play more of these games. They're free. Okay, and then I put this slide in here just to give you a very tangible, real-world example of how psychologists use R. So I was trained in industrial organizational psychology. That's the easiest way to think about it. It's just psychology applied to work. And what you see here is you have different kinds of tests that somebody can take in order to get hired for a managerial kind of job. So IO psychologists devise selection tests which they hope will predict job performance. So a good test will be one where the people that score high do really well on the job and the people that score low do really badly at the job. If you have that kind of relationship, it's a good test. So how do these different things do in terms of predicting job performance? Well, if you look down here at the bottom, somebody that tells you they can predict managerial performance based on handwriting analysis or projective personality test is probably lying to you. Or if they're not lying, they're just ignorant. But projective personality test, that's like a Rorschach where I show you some blob of ink and I say, what do you see here? And if you say, you know, I see 2 sons of Satan fighting over the state of the planet, you might learn something about their psychological disorder, but that's not going to be very helpful in predicting job performance. Then if we move up, it's a little better to know how much education they've had or their college grades, but the R values aren't that great. It's only 0.10. And then you get up here, it's better to do an interview. Most of us at some point suffered through an interview. Most interviews, or at least a lot of them, aren't structured interviews. In other words, you can get off topic. So if you look here, what's the difference between interviews and structured interviews? You get a lot better if you have an IO psychologist or somebody making sure that the interview protocol focuses on what are called job relevant criteria. In other words, you're asking people about the kind of work they do. So for example, when I was interviewing for a teaching job, one of the questions I got was, tell me about a time where you were trying to teach something and it didn't work well and how you realized that and what you did to fix it. So that was an example of an interview question that's going to give them good data that will let them see into my thinking process about how I might handle my teaching. And so that R value is a little bit better. Experience doesn't hurt, but again, it's not a great predictor. Once you get up here at the top, the things that tend to work the best are job knowledge tests. So you're actually asking them specific questions about how they would do the job. This is probably pencil and paper kind of thing. And then cognitive psychomotor ability tests. Here, basically, we're talking about some kind of IQ test. Like the SAT is basically a kind of IQ test. So in IQ is this ability, general cognitive ability to adapt and perform well in different kinds of situations. So it's not surprising that it's fairly predictive of job performance. Okay, so in other words, just to summarize, these are different values of R. As they go up and get higher, you're doing a better job at being able to predict who's going to do well in a job situation and who's not going to do well. Okay, so some comprehension questions. Go ahead and stop this and try to answer these, and then we'll go over the answers. Okay, so as R gets stronger, the slope of the line gets steeper, gets further away from horizontal. When R approaches 0, the slope of the line is nearly flat or horizontal. And then which of the following R's is the strongest? Question 3 here. The strongest one is actually this negative number, negative 0.55. Remember, negative doesn't mean weak. It just means it's an inverse relationship. The weakest relationship here is this 0.02. That's probably, again, at the population level. It's very unlikely that there's a real relationship there. Okay, and then the last part of this lecture, some limitations of correlation. There's 3. 1, it misses curvilinear relationships. So imagine that you have a relationship here plotted between anxiety and performance. So if you're really, really unanxious, you're just so relaxed that maybe you're sleeping or you're just walking around saying, dude, do I feel good? You're not going to be very focused on doing well on the test or whatever the performance is, and you're likely to not do well. On the other extreme, if you're so stressed out about the test that you can't remember your name, you can't remember how to hold a pencil, you're seeing colors and weird shapes from hallucinations, etc., that means you're not going to do very well. So the actual optimal performance is here in the middle, where you have a medium amount of anxiety. So this is a curvilinear relationship, and you can tell that by if you try to draw a line that summarizes it, it doesn't really work because it's a curve. So the deal is Pearson's R can't detect this. It'll look at this and say, yep, there's no relationship. There actually is a relationship. It's just not linear. It can't be summarized with a line. So even though there's something going on, the R would be near 0. So it's a good idea to do a plot of your data to make sure you don't have curvilinear stuff going on. Fortunately, most of our data don't come to us. Most of our relationships in psychology that we look at aren't curvilinear. They are linear relationships. Okay, the other problem that can happen is you can have this thing called truncation. That means like you have an elephant trunk and you cut it off. No, truncation means you have some range and then you restrict it. You, instead of having something out to 4 digits, you just cut it off, it's out to 2 digits. In this exact case, what we're talking about is you want to have a range of test scores and a range of job performance scores so you can see the full extent of the relationship. But imagine that if someone scores, say, 12 on this hiring test, you don't hire them. And that means you don't have this data because you don't get the job. And the folks over here, say at 22 and up, these are folks that they get the job. No, excuse me. They do well on your test, but they don't take your job. Maybe they get hired by your competitor who pays more. So you're left with just this wide area in the middle, and it doesn't look like there's a relationship. It looks like there's not much going on. Well, the reason it looks that way is because you've had truncation of range. You've had this range of the X value shrunken into this small area. So that means R is going to underestimate the strength of the relationship. So if you're missing data, basically, you're going to miss part of the story. Okay, then the last limitation that's important to keep in mind is that a correlation doesn't mean that there's a causal relationship. Two things can be going on. So let's imagine that you have a situation where you see a relationship where as swimming happens, there's more ice cream consumption. So looking at different days, those days where there's more swimming going on, there's more ice cream consumption. So if you assume swimming causes ice cream consumption, you're getting suckered because there's this third variable, higher temperatures, that's explaining both of them, that's making both of these happen. And then consequently, it looks like it might look like one's causing the other, but there's this third variable that's in charge. High temperatures causes both. The other thing that can happen is you can be confused about the directionality. So when they were first looking at autism, and autism is this developmental neurological kind of disorder where people have a different way of interacting with the world. They tend to be less emotional and very fixated on certain stimuli. So it was thought that there's these cold mothers out there, these emotionally distant mothers that are causing autism. But the more they looked at it, they realized it was actually the other way around, that the autism was causing the mothers to have a different style of interaction with their children, which makes sense. If your kid is a little distant and engages in the world differently, you might not show the same kind of traditional warm babies kind of talk with your child that other parents would. So in fact here there was confusion about which way the arrows were flowing. Okay, so those are the three limitations of causation, and that's it for this lecture 3.2. Thank you.